Alright guys, today we're going to go ahead and be taking some notes on reviewing energy, just what you need to know for the test. Now before we begin, let me just say that this is not going to be everything you need to know for the test, so you definitely want to be looking over whatever work you've done, whatever we've done in class, whatever other notes you might have that exist relevant to the topic at hand. But we are going to be covering some points that I feel like are the most challenging and problematic areas that will be on your test. One thing I want to do is I want to go ahead and just give you guys a little quote from one of our teachers here at the school. Across the hallway, you might know Mr. Rourke. One thing he likes to say is that you deserve your best, and I want you to maintain that at the forefront of your mind as you begin this note-taking process. Just make sure that you understand that everything you do with taking these notes and studying and reviewing these notes is going to be benefiting you and your grade. All right, so we're going to go ahead and take a moment to set up our paper. I want to remind you that you do not need the entirety of those 6 lines at the very bottom of the front page of your paper. 4 lines is enough, but go ahead and set that paper up. Just draw the lines, don't write the words, but this is just a reminder what each section of the notebook is used for. And I'll just pause while you take a moment to do that. All right, we're going to go ahead and start by writing down the kinetic energy and potential energy formula. And we want to make sure that we have both of those there for us. Make sure that you add a question mark here. That is a question. And then over to the side, I do have the formula. So remember that this is Ke equals 1/2 mass velocity squared. But I just write it like this: 0.5 times mass times velocity times velocity. I feel like that is probably easier, but it's the same exact formula. It works the same way. And then for potential energy, this is going to be the energy of position or situation. And we have both gravitational and elastic. And the formula is GPE equals mass gravity height. Remember that gravity number right there is always 9.8. And I'll just pause for a moment while you take some time to get that down. We want to go ahead and we want to define energy. So energy is the ability to do work or change the environment in some way. And the next thing you want to add here is energy will flow from high to low. So if you have what we call a difference or a differential in science, we can see that energy will flow from an area that's high, where it's highly concentrated, to an area where it's low or it's not as concentrated. So energy flows from high to low. Thank you. So here's the idea. Before I go on, I want to go ahead and make this very clear. In order for heat to occur, there has to be a difference. So if you have, like, let's say you have a cup of water and there's a piece of metal going to another cup of water, and this water on this side is 58 degrees and this water on this side is 20 degrees, then what you're going to see is this energy is going to flow over here until both of the containers reach a temperature of, like, let's say, and I'm just using some estimations here, let's say 30 degrees, right? They'll just the energy will flow until both of these are 30 degrees. However, if you start out and both of these are 30 degrees when you begin, the energy is not going to change. They're going to be the same because there's no heat that's going to flow. There has to be a difference in order for energy transfer to happen. And if there's no difference, it will not happen. We're going to go ahead and we're going to sketch this roller coaster onto your notes underneath that statement we just wrote. Now, at area 1, this is where you're going to have the highest. That's wrong, actually. Let me go ahead and correct that. At area 5 is where you're going to have the highest potential energy. Okay? Where on this chart are you going to have the greatest kinetic energy? Well, that's going to be at number 3. That's where you're going to have the greatest kinetic energy. One thing I do want to say is that as you keep going back and forth by changing from one type of energy to another, you're going to have to remember that you're going to be losing some of that energy because of the heat, because of transfer, and that's going to become thermal energy. So anytime you have an energy transformation, you have some thermal energy that is produced. Remember, the reason that this is the highest potential energy is because GPE equals mass, gravity, height. And the reason that this is going to have the greatest kinetic energy is because it's moving very fast. And so you're going to have KE equals 1/2 mass velocity squared. Okay, so just remember that. That will be asked of you on a test. Make sure you're able to recognize that. Chemical energy would be energy that we get from chemicals, that would be food and batteries. Remember that batteries are used to convert chemical to electrical. Okay, so anytime you're using a battery, you are converting chemical to electrical. And by the way, while you're writing these notes, I want to encourage you, you can add, change, modify however you need. Just what I have in this presentation is the minimum of what you are going to need, the minimum. But I do expect you guys to have more than what I have. Again, what I just said to you, energy transformations, energy changing from one type to another, that is always going to cause some thermal energy. What are some examples of energy transformations? That's a question you need to have in the left margin. Go ahead and take a second to get that down. We're going to pause while you do that. We're going to go ahead and begin to fill in this table. So as you look up here, you can see that if I'm using batteries in a flashlight, that is chemical energy becoming electrical energy. When the sun shines on the plants and the plants use carbon dioxide and sunlight and water, they produce oxygen and sugar that is using radiant energy to produce chemical energy. And then we have a couple of other transformations here. Now, this is not all the transformations, so certainly I would like for you to add an additional one to your chart if you can think of one. and I'm going to give you a chance to kind of like, just turn to your neighbor and see what you guys think should be here in this last little box that I want you guys to add. But using a blender or using a fan, anytime you plug something in and it makes it move, that is electrical to mechanical. And then we have potential to kinetic. Remember, if you have a hill and a ball begins to roll down, just like on a roller coaster, you have that potential energy turning into the kinetic energy. By the way, we would call this gravitational potential energy. And we have some other types of energy we want to mention over here on the side. Mechanical, radiant, and nuclear. I'll give you guys a chance to add that. We're going to go ahead and pause while you take a moment to add that. And we're going to go ahead and define heat. Now, I want to remind you guys that heat is the movement of that thermal energy. It's where thermal energy will move because of conduction, convection, or radiation. So we have these different definitions over the side. Let's just take a moment. Let's get these down, and we'll pause the video until you're ready to move forward. So one thing I want to remind you of is that if there's no difference in the amount of heat, then there's no difference in the amount of thermal energy, then there's not going to be any kind of a transfer. There has to be a difference for this to happen. So I just want to remind you of that. All right, and then now we have heat is that movement of thermal. Below, I wanted to draw a picture of something for you. This is what we would call a convection current. And just know that this warm air is going to rise, and these particles are then going to pass on their energy. And then after they pass on their energy, they become cool and they come down. Now, the reason the warm ones go up is because they have a lighter density. And the ones that have less energy have a higher density, and so they come back down. They're heavier, they're more compressed, so they'll come back down. Whereas the ones that are higher energy, less density, are going to rise up, and that's how you have that circular flow of the particles in a liquid or a gas, collectively known as fluids. Right? So these are liquids and gases that these mostly occur in. All right. The radiation, great example of radiation is going to be the sun giving off its light to the earth. That is radiation. There is no matter in space. There's no air in space. So that energy transfer occurs without the need or the use of matter. You do need to have this illustration right here in the notes. If you do have some colors, you can add those to your notes to make them look nice. And we'll pause while you get that little sketch there. And now it's time for the summary. Now, again, I want to remind you guys that as you're doing this, you should have 5 differences between what I present to you and what you actually have. I want you to have 5 things that you add. Again, these can be addition of vocabulary terms. These can be some sketches or any other kind of nonverbal representation. I'll just say nonverbal rep. There we go. You could have a diagram if you wanted to, or you could have just additional facts in the notes. But 5 things that give your notes character. Now, one thing you could also do is you could also take my summary and change it into your own words. That would be one of those 5 that I'm looking for. I'm going to go ahead and just give you guys a chance to finish that up today. And I'm going to say thank you for your hard work and your diligence. Thank you. And when you're all done, this is a general appearance of what I should see in your notes. If you needed to use 2 pages, that's totally fine. But I just wanted to make sure that you guys were comprehensive of everything we need to have. Thank you very much, and good luck on your test.